Hello, everyone, and welcome to our webinar, How to Maximize Uplink Performance Benefits in Gigabit LTE. I'm Lindsay Kelly, VP of Digital and Content Marketing here at Telit, and I'll be your moderator for today's event. So before we start, I would like to gauge an idea of your involvement with non-consumer high-speed cellular projects. So please take a second to fill out our poll question, which you should now see on your screens. Thank you very much. Here we go. All right, and so while that's going on, I'm going to go ahead and I'm going to get to know our two speakers here today. So to explain this topic, I'm pleased to be joined by two wonderful speakers. First, we have Donna Johnson. Donna is the VP of Product and Solution Marketing at Cradlepoint. And second, we have Safi Khan, and he is the Regional Product Marketing Director at Telit. And so before I hand over the presentation to Donna to get us started, a few quick reminders. I would like to encourage everyone in the audience today to please interact by posting questions. We'll have some time at the end of the session today to get to some of those. So simply submit that by posting in the box to the right of the slides. You'll see a couple tabs at the top there, so there's one for questions. And then finally, we will be sending out the presentation slides and a replay link to everybody who has attended today at the conclusion of the webinar. So, with that, Donna, I'm going to hand it over to you.
Thank you very much, and thanks to everyone for joining us today for this topic. It's a really interesting topic. We're going to cover a lot about wireless, how it's used, how Gigabit LTE is used, and then dive into some great technical details on what happens underneath the covers. So to begin with, I want to paint a picture for you of today's WAN. I think many of us who've been in networking for a while think of a WAN as a traditional branch connected to a wired link, usually MPLS, and people sitting at their computers, at their desks, a fairly static version of a WAN. But if we look out today and really see how businesses are connecting, we can see that the WAN has spread very far from that original vision. It often is connecting vehicles. It's connecting people in all sorts of different locations, whether they're in offices, whether they're in their homes, whether they're out and about at pop-up locations. It's being used to connect IoT at things as diverse as oil and gas, security. We even have an application where we're literally connecting cows via a WAN. And it's being used in businesses all over the place, not just traditional branches, but restaurants, pop-up locations, and a lot of temporary networks, which we've seen particularly throughout the last several months. So I would argue that the WAN itself has expanded greatly, and that in large part that is due to the abilities of wireless. Wireless has moved beyond the way we always thought of that traditionally, which was largely as a phone connection, to really being a very credible and in some case best choice for connecting WAN. And at Cradlepoint, the idea of a wireless WAN, one where businesses really can be untethered from wires and really can be free to connect anywhere and to connect anything, is really something that's growing. We see more and more of our customers and more businesses at large turning to wireless as their connectivity source. And the idea of a wireless WAN is really growing strength. And a wireless WAN is one that really relies on a cellular network, not one that uses it as a failover, not one that you use it occasionally, but one really where the WAN itself is dependent on that cellular connectivity, potentially with a wired option or maybe just cellular on its own. And the capabilities that open up once a business untethers itself from wires is extraordinary. It really gives organizations the ability to expand and reach, whether that's reaching out to where their customers are, reaching out to where their employees are, or just reaching out to be able to access data in all different kinds of places. So if you're on this call, you're obviously well steeped in wireless and are interested in it. So you may be asking, should we turn to a wireless WAN? Should we allow our business to depend on cellular? And why would we do that? And there's really four key reasons why businesses are looking towards wireless as their connectivity source. Number one is the ability to use it anywhere. Once you're not limited to an office, you're not having to wait for a wired link, whether it's broadband or MPLS, to be provisioned. You're really free to open up locations or to access data or collect data from anywhere. We see this, and we'll talk through some of the use cases, but this is probably one of the chief benefits of a wireless WAN. The second is that you can deploy quickly. If you are in IT and you've ever had to wait for an ISP or a broadband link, you know that sometimes your business can be at the mercy of your ISP or your carrier. With wireless, it's ubiquitous. It's almost by definition anywhere and at all times. So if you have a location that needs to open, or if you need to open in a new location, that network is immediately available to you. So this ability to deploy quickly on your own schedule is really a chief benefit of wireless. It's adaptable. It's easy not only to increase your data, to increase your data plan, to change things. Obviously, it allows you to move easily. So as your business needs to adapt, your network can adapt with you. There was even a story over the last several months as more and more people depended on wireless for at-home work. The carriers were actually able to add spectrum dynamically. So literally the network itself was able to adapt to demand. That's an agility that a traditional wired network doesn't have. If you want to increase capacity for a wired network, sometimes it can take a lot of time, but it also may require you actually to wait for modified connections. So that adaptability is and has been very important to our customers. And then the fourth really is this ability to reach. Commerce in particular, but all types of businesses are not as static as they used to be. Retail can't just open up a storefront and expect customers to come to them. Tax preparers don't necessarily have customers coming to them. Many of these businesses need to go to where their customers are, whether it's opening up a location inside of a store such as Costco or Walmart, whether it's opening up a retail location at an outdoor event, whether it's moving your entire delivery mechanism to the curb. This ability to go to where your customers are is really critical to today's commerce. And wireless gives you the ability to do that because you're basically able to take your network with you. And all of these benefits have been made more than clear during the recent pandemic. COVID-19 really had a way of clarifying what was important in networks as many businesses, including ours and probably yours, scrambled to respond to it. And one of the first things that we at Cradlepoint saw was immediate demand for pop-up networks. And this was particularly true in our public sector and healthcare businesses. Healthcare companies needed to open up clinics within a day. We actually took orders in the morning, shipped them out that afternoon, and the clinics were up and running by the next day. This was an extraordinary demand. This is not business as usual, but it really demonstrated the ability of a wireless network to allow you to create a fully secure, high bandwidth office, in effect, in a parking lot in 24 hours. We had companies use it to set up immediate quarantine sites, particularly some of the military and government agencies. Various government agencies that need to set up mobile command centers, all of those were able to do that by using wireless as their connectivity source because, of course, they weren't able to be using the buildings that existed. Work from home was one of the second waves of demand that we saw, where workers who were sent home, as probably many of you still are, needed to be able to create a secure network, one that was potentially isolated from their home network, whether for security reasons or quality reasons, and ones that had abundant bandwidth that they could be able to conduct their normal operations from home. So they took home wireless routers, the ability to use cellular as their connectivity source in order effectively to recreate their office environment. And one of the most interesting uses we saw of wireless during COVID-19 was for students. So, of course, students were also at home. Many of their courses were online, but we saw a real inequality start to manifest itself as some students didn't have good broadband at home. And so wireless was actually used to create pop-up networks, either through vehicle-mounted routers or building-mounted routers, where students were actually able to access their learning resources, their classwork, and their teachers via a cellular network. Obviously, no one expects this to happen again. This was really a set of extraordinary circumstances. But it was a time where businesses really were able to see how wireless, with its agility, with its ability to create a network anywhere, with its some of the inherent security, reliability, and most importantly, bandwidth capabilities, really was able to help a lot of companies respond to COVID-19. And I think it demonstrated its value even during normal operating periods. So what are the characteristics of a wireless WAN, and why are companies looking at using Gigabit LTE and other LTE sources for their WAN? Number one, particularly with solutions such as Cradlepoint, they are complete solutions. They have the full routing capability, full security stack, as well as that WAN source all built into it. So you basically have a network, a fully resourced network with you wherever you need to open a location. A wireless WAN can connect a converged edge. So if we talk about the fact that a branch is not a building anymore, a branch is everywhere your employees are, then that might be mobile, it might be connecting kiosks, it might be connecting IoT, and of course it might be connecting people at home. And so a wireless WAN gives you the ability to have a single WAN source and a single connectivity and management source for all of that WAN. All of those WANs, all of those different locations. A wireless WAN lends itself towards zero-touch deployment because the network is already there. If the modem is already integrated, you simply need to turn it on and connect. In the case of Cradlepoint, pull down the configuration and you're ready to go. So you don't need to have IT staff. Again, that was something that was very important during the COVID response because these pop-up locations didn't all have IT staff on site. It's manageable at scale. It has to support current cellular technology. And that's one of the things we're going to talk about today is cellular is great. But many of you on this call know there's very different flavors of cellular, whether it's 3G, 4G, Gigabit LTE, or 5G. And it's important as you look at using cellular as a WAN source that you're always on the latest version of that network. And that's really what's going to give you the bandwidth and the reliability that you need. A wireless WAN is generally one that can be operated with a small staff. And again, it's all-in-one with fit-for-purpose endpoints so that no matter where your WAN is, whether it's a vehicle, whether it's out in a field, or whether it's in an office, you have the right router to support that. So we can ask ourselves, are businesses using LTE as a WAN source, and how are they doing that? And we actually just conducted a survey with several hundred businesses with IDG to understand how businesses are using cellular, how are they using Gigabit LTE, and is that changing over time? And we definitely still see that many companies are looking at LTE as a failover link. Meaning that they have a wired link that they use for most of their traffic, but they use cellular as a failover. And that's been a traditional source of LTE. It's still a great source, particularly, there's a lot of locations that maybe can't get a second broadband link, but they still do want to use wired as one of their sources. One of the benefits with cellular as the amount of bandwidth increases, which we'll talk about more today, is that if you do need to use cellular as a failover source, you can count on that cellular link having sufficient bandwidth to match what was on your wired link. So if you have DSL or cable or MPLS as your wired link, you want your backup link to have the same amount of bandwidth so that you don't have to sacrifice applications during a failover scenario. So as the bandwidth availability on cellular has increased through the use of Gigabit LTE, it's increased its effectiveness as a backup link for a wired link. We see companies increasingly using it to augment a wired link, meaning that they're using both the cellular and the wired link simultaneously which allows them just more bandwidth. It's an additive factor. And again, the more bandwidth you have with wireless, the greater that impact can be. We do not yet have a majority of customers using wireless as the only link in a branch, but we are seeing that grow. And at this point, we have 39%, which is a fairly large number of the businesses we surveyed, using wireless as the only link in at least one of their locations. And another 40% almost who are considering doing that. So we definitely expect in the next couple of years for more businesses to be looking at wireless as their sole connectivity source in some or all of their locations. Now, when we ask them why, many of them are using it in a branch, but many people are also using wireless to connect other things such as digital signage, other types of IoT, including security cameras, and to connect vehicles. And all of those are use cases where the amount of bandwidth needed is growing. So digital signage isn't just a static sign anymore. It's often bidirectional, collecting data, as well as sending down rich multimedia. IoT data usage is growing, and of course, vehicles, which we'll talk about, are incredibly rich source of data nowadays connecting over wireless. So Cradlepoint does have a portfolio of products that are incorporating Gigabit LTE. We are using the Telit Gigabit LTE or Cat18 modem in our Gigabit products. We launched that in 2018, December, on the AT&T network first, partnered very closely with Telit on that. This actually was the first enterprise use of Cat18 or Gigabit LTE that we know of in the market. We both learned a lot from that experience, but it's been incredibly successful for us since then. We have solutions that connect branches, that connect mobile vehicles, and connect IoT. We have expanded from AT&T to Verizon, all of the other major U.S. carriers, and now worldwide. So we have Gigabit LTE applications from Australia through Europe and into South Africa. And again, we were able to partner with Telit on all of those opportunities. And this month, we just announced our E3000, which has the Telit Cat18 modem in it, which has 2.3 gigabits of throughput capability that allows us to basically have our routers capable of supporting the large throughput that Gigabit LTE supports, and built with 5G optimization in mind, so that as we move to 5G, we'll be able to insert a 5G modem into that as well. And as I mentioned, we do have different form factors that are really fit for purpose, whether it's branch, whether it's mobile, or whether it's failover. So even if you're using wired and you want to use Gigabit LTE as a failover source, that capability exists. So let's talk a little bit about how people are using Gigabit LTE today and some of the use cases where we see the real strength of Gigabit LTE come to the forefront. So I mentioned PopUp Healthcare during COVID-19. That was really a case where Gigabit LTE was very strong and really showed its value. If you think about a healthcare location today, it's not just a patient going in and talking to a doctor. The doctor or the medical professional is often on an iPad, some other type of data source that has to be connected via Wi-Fi and connected to the internet. The medical records are often stored in the internet or in a data center somewhere. In pop-up type of healthcare, you may not have a specialist or a doctor on staff. That may occur via video conference, so you have a very rich media stream, both upstream and both up and downlink. So you need adequate bandwidth in both cases. And even in pop-up healthcare, as well as in traditional clinics, you may have the patients themselves on Wi-Fi. So you have patient use of Wi-Fi while they're waiting, and then you've got multiple medical devices. If any of you have been in the clinic or hospital lately, you know that almost all of the medical devices, the monitoring equipment, and everything else is connected either via Ethernet or Wi-Fi and is often monitored externally. So that's a lot of data going back and forth. And again, in a lot of cases, these were in clinics that were set up in parks and parking lots. So they relied 100% on Gigabit LTE for that connectivity. Wireless branches, customers, the 40% we looked at that are moving to an all wireless network, they have a high demand for high bandwidth, whether it's doing voice, often increasingly doing video consultations from a retail location. They have IoT. They may have IoT doing occupancy counts, doing rich media applications, as well as just surveillance video. Of course, they also have guest Wi-Fi. And these wireless branches have an expectation for high bandwidth. This is not something that this is something they take for granted based on their use of wired links in the past. Video surveillance is probably one of the largest use cases we see for Gigabit LTE, whether it's public or private use of video surveillance. Increasingly, these are high-def videos, 4K videos, and they're being looked at live. So it used to be videos would stream data to a DVR, and the DVR could be picked up later. But now the desire, particularly with smart city applications, is for that video to be viewed live. And so you've got to be able to upload large amounts of video data over the wireless network. We talked about work from home. That's been a great use of wireless. But if you think about what you do in your office or your home office, it's not just downloading. This is not a consumer application where the requirement is just to download movies. You're often doing a lot of uplink, whether it's video chat, video conferencing, or just working with large files for your day-to-day business. So the need for Gigabit LTE performance, both on the upload and download, was really brought to the forefront during work from home. And then it's used a lot in transit. Our mobile vehicles, whether they're police vehicles, whether they're buses, they could be school buses, but they also could be mass transit. They're offering guest Wi-Fi. The mass transit really has a desire for people to come back to them. And so one of the ways they're doing that is by offering guest Wi-Fi for the passengers. But many of those passengers, of course, are using large amounts of data. You also want to be able to collect AVL information from transit and buses, including location information and vehicle information. Many of them have security cameras, which you'll want to stream. And then you may need to reach into the buses or other types of vehicles to do remote management, to actually do diagnostics to onboard computers and other types of tech. So again, the need for both up and download performance in those vehicles is only grown. So those are 5 use cases that we've seen where not only is Gigabit LTE critical to the success of that use case, but the upload performance is important. And again, I can't stress enough, this is not a consumer application of use of Gigabit LTE. We're not talking about downloading movies and games. We're really talking about a robust synchronous communication. So Cradlepoint and Telit have been a great partnership. We've worked together very well over the last several years and really have pioneered Gigabit LTE use inside of the enterprise. And it's been great working with them, and it's been great doing this webinar with them. And with that, I'm really excited to turn it over to Telit and to Safi to talk a lot more about the technology that delivered some of the use cases that I just covered.
Okay, great. Thank you, Donna. Hello, everyone. My name is Safi, and great to be here. So that was a great introduction, Donna. I think I learned a lot from all of your content. So let me switch gears a little bit and get into the nuts and bolts of how we achieve this wonderful technology, and try to explain to the audience how some of the factors play into achieving Gigabit LTE. So let's start with this recipe for Gigabit LTE. Now, Gigabit is actually 1 million bits. As you can see, Giga is 1 million bits per second. And so it's a significant milestone actually on the road to 5G. But in LTE, this is the highest speed they have achieved, which is the 4G. And by offering gigabit per second download speed, the operators can meet the rising expectations of network performance. As like Donna said, users then they can do live streaming, they can share increasing volumes of video content, collaboration, especially in a mobile environment. So one of the best advantages of a mobile cellular network is that you could be connected anywhere, especially because now we have come to expect pretty much ubiquitous coverage, blanket coverage, wherever we are. And so the demand for data, as we all know, has increased significantly, and people now expect broadband-like experience wherever they are. So the operators who keep their networks at the leading edge of performance have shown to have better user satisfaction, more loyalty by customers, more ARPU, which is the revenue per user. So how do they achieve that? So there are actually three main components or ingredients that go into this recipe. And so let's say the first one, which we want to target more detailed discussion today, is called carrier aggregation, which is abbreviated as CA on this slide. And so there is carrier aggregation in the downlink and also in the uplink. And today we will focus on uplink more. But let me just explain that these so-called carriers, these are chunks of the radio spectrum or radio frequency, which could often be non-contiguous, so they are in separate frequency bands compared to each other. And the operators enable a combining of these or aggregation of these to increase the data rate that a user can experience. And by combining them, it essentially means if you have a highway, you're basically adding more lanes in the highway. So you're making it wider so that you have higher data or more number of cars, as an example, that can go through that highway. So in Gigabit LTE networks on the downlink, a typical carrier aggregation combos or combination can be up to 5 carriers, and each carrier is 20 megahertz, so it can be up to 100 megahertz. On the uplink, it's more constrained because the devices don't have the luxury of a base station of a network because it's not fixed. It's portable, sometimes battery operated, but sometimes space constrained. So on the uplink, 2 carriers can be aggregated to basically double the speed. Now, the second ingredient for Gigabit LTE is higher order modulation. Now, to explain this, a good analogy is basically that you can pack more bits into the same packet. And so you're increasing the efficiency of how you're transmitting this information over the air. So in Gigabit LTE networks on the downlink, you can go up to 256 QAM, which is quadrature amplitude modulation. It's a technical term for how the modem encodes the information, which is then received by the other end. And on the uplink, the Gigabit LTE modem can achieve 64 QAM in the uplink. So basically, it's an upgrade from 16 QAM. So as your QAM order goes, it's in the powers of 2. It goes from 16 to 64 to 256. You're able to pack more densely the number of bits, and hence you achieve the gigabit speed. And last but not least, the third ingredient is called MIMO, which stands for multiple input, multiple output. And essentially here what we are talking about is the use of 2 or more antennas to basically send more data and also achieve the spatial diversity and leverage copies of the same data that reach the receiver and has a higher chance of getting a successful transmission. So with the Gigabit LTE, the provision is to allow up to 4 antennas, both on the transmit and the receive. So these 3 ingredients basically provide you a recipe for Gigabit LTE. Now, also in the industry, there is efforts to increase the spectrum availability. Of course, there's the licensed spectrum, which the operators pay for, and it's exclusive use. So it's something that's not shared, so you don't experience the interference from somebody else. But there's also many spectrum chunks that are now becoming available in North America by use of free or shared or unlicensed spectrum. The first case of that is called LAA, which is Licensed Assisted Access. This is the Wi-Fi spectrum band, and as you may or may not know, so the Wi-Fi operates in spectrum which is basically free. There is no license, but you have to follow certain rules to make sure that you don't interfere with other users. And so with LAA technology, cellular LTE modems are also able to operate in this frequency and do carrier aggregation, and basically use LAA frequency as an extra lane that they can add into their highway. Similarly, in band 48 3.5 gigahertz, there is a frequency band called CBRS, which is Citizens Broadband Radio Service. This is also spectrum from the FCC that is becoming available for shared use, and it is not exclusive license. It's more a three-tiered licensing system where there is a free component, then there is a paid component for exclusivity. And this was used by the government and the Navy, but they have opened it up for cellular use. And also for band 14, especially in the case of AT&T in 700 megahertz, there is provision to have extra frequency available mainly for public safety, first responder kind of use case. And then there was band 71 in the 600 megahertz range for T-Mobile and others that also adds additional capacity. So let's keep going and focus a little more on how this Uplink CA helps a lot of the use cases that we will talk about. But let me just show you the state of the Gigabit LTE networks is. This slide is coming from the GSA Corporation because it's basically as new as May of this year. So as of last month, there are a total of 327 operators in 138 countries that are investing in at least one of those three technologies for Gigabit LTE. So those three are, like I said, carrier aggregation, higher order modulation, and MIMO. 46 of those have deployed all three technologies. So that would include the operators in North America, like AT&T, Verizon, and T-Mobile. And many of these operators, as you can see, are already also investing in all three technologies. So very soon, more and more operators will have Gigabit LTE. And then 37 operators can actually support the Gigabit LTE speed today. So they already deployed it, they already launched it, they already made it commercial. So now you can actually enjoy that speed on your smartphone or tablet, which is LTE enabled, or as Donna said, you could enjoy it for a wireless router, gateway device, or a branch office device, which instead of a wired connection is connected by a wireless connection. So you can think of the advantages that this can bring and the use cases, the tremendous amount of use cases that it will open up. And I will also touch on some of those use cases later. So today's webinar is going to focus on uplink and especially interband carrier aggregation. So let's dive a little deeper into the technical details of how this is achieved and what are the differences between two types of carrier aggregation, intraband and interband. So one thing we know is that if you increase the channel bandwidth, you achieve higher data rates. This is what I said in the beginning. Think of the highway example. You're adding more lanes, meaning you're combining more carriers to use in your transmission. Now, combining the LTE carriers can be done in two ways. So, intraband is a technique which combines the component carriers within the same RF band. Now, the same RF frequency band is something that is not very prevalent because typically the auction by the FCC auctions the spectrum and they typically win the spectrum in different frequency bands. But some of the operators in fewer cases have been able to achieve or accumulate spectrum in the same band. So they can leverage intraband CA combinations. Now, the more typical case is interband, which means across different bands. And that is the use case on the lower right, where you have a frequency band A and a frequency band B that an operator owns. Now, these could be completely different frequencies. But because of interband carrier aggregation technology, the modem is able to combine carriers from these separate frequency bands as if they were being combined into one unified channel. And this is what the Telit design module that's used in the Cradlepoint device, the router, is able to do. And so this is the crux of the recipe for really achieving the 150 megabits per second in the uplink, which is essentially a highest achievable speed in the uplink. And that opens up a lot of the use cases that I will talk about. So there are some design challenges to achieve that, which I will also cover. But just so you know, the RF frequency bands, because they are separate, they need different hardware, they need parallel hardware that can tune simultaneously to two different frequencies. So as you can see, when you go from intraband to interband, you're basically increasing the probability or the operational flexibility that you have, where no matter where you are in an urban setting, there's a high likelihood that you will find a network from a carrier that has deployed this technology. Okay, so now let's talk about the many use cases that Donna already touched on, and I will just further expand on it and just talk about how it is affecting the industry and how these two things, the Cradlepoint router and the LM960 module from Telit, have really changed the business and this basically market. We're leading and driving this market to open up these new cases, new use cases, and especially the cases where the uplink is very important. So SDWAN stands for Software-Defined Wide Area Networking. So you may be very familiar with a LAN, local area network, and a WAN, which is a wide area network. And it used to be wired, but now this is essentially a wireless WAN, and it's the enterprise branch office networking is the main use case. And Donna already touched on very good points on why it's needed, what are the use cases. Here, it's just expanding on a few more aspects of it. So as you can see, it's inexpensive to deploy, and it's a very efficient solution for providing instant or near instant internet connectivity. Business users can basically now have real-time communications with their clients right away. Video, which is very important, especially in video conferencing, and especially in the current pandemic situation, teleconferencing systems. And then, of course, for branch office, it's important for keeping their data into the cloud for file storage and backup. So this is one of the main use cases that we have seen a big traction for this. And the reason this is so successful is that you get a decent, very high uplink speed, which previously was not possible. Video broadcast is another use case, like already touched on in the case of basically, people love to chat on video, and being able to essentially see the other person, their body language, their emotions. So video has become very important, and for video, uplink is the key, because when you have a mobile device, you want your video to have low latency, no lag, and smooth operation. Similarly, online gaming has become a big industry. As you can see, of course, now you don't really have to be tied to your home. You could be playing online gaming anywhere. Like I said, wherever the network provides you connectivity. E-education and advanced telehealth are again really strong use cases. Donna already touched on those. Medical professionals want to send images and scans of patients, including even videos, and all that is uplink, relying on uplink. Same goes for emergency management operations and first responders in the field. In the unfortunate case of disasters, rescuers on site are typically in a remote area, maybe a fire or something else. Hard to reach location. There is a need to upload high-resolution images from the field, and the only available option to them could be to connect using LTE or a cellular network. And as Donna said, the speed of deployment is the key here, where you can quickly power up a router, connect, and do some configuration through a GUI or graphic interface, and you're up and running. And of course, mobility is an important point that I touched on earlier. So an LTE cellular modem and a router can basically deliver enterprise-grade connectivity to mobile applications. So basically, you can have always-on connectivity. This is further more technical details, so I won't go too much into the science behind it, but I just want to touch on a few key points. So in Interband uplink carrier aggregation, the module that Telit designed included specialty components that are required to achieve the Interband carrier aggregation. And this is done by basically having a parallel RF chain. The whole chain has to be replicated, so that one chain could be operating on one band and the other chain could be operating on the other band, and then you combine them. As you can see, the frequency combinations of the couple of operators, as well as T-Mobile, has very similar combinations as AT&T. So all major operators in the uplink combine bands from different frequencies. So as an example, if you want to combine band 2 and 5, you can see that these are the combinations that are required in the device to be able to support that operator. So your one RF chain has to be on 1900 megahertz frequency, which is band 2, and the other chain would have to be tuned to 850 megahertz, which is band 5. So these are completely different frequency bands, and you cannot achieve this unless you put the right hardware into the module. So essentially, the bottom line is that without this interband two-carrier aggregation, there is no 150 megabits uplink, which is realistically achievable. And the only way that's achievable for a non-handset, meaning a router or a IoT device, is by using the module that we designed for Gigabit LTE, which is the LM960A18. So that's the module I want to talk about next. And in this module, as you can see, we set out to basically design the most extensive set of carrier aggregation combinations, and it's fully certified, globally certified data card. And if we compare it to competitor modules, they did not implement interband carrier aggregation. They did implement intraband. Okay, so in some cases that does work, but in most of the cases, when you need to combine two different bands, the Telit LM960A18 is the only data card on the market which is capable of reaching 150 megabits per second in the uplink. And so I think Donna mentioned that it also has been deployed globally. So one of the important things in terms of the Telit strength and leadership is in mobile broadband, we have basically global availability and certification. So this is very important for customers like Cradlepoint, where you win a big market in North America, which is the leading market, but then you want to expand globally. And because of our module having global certifications and a single SKU, it makes this possible. So you can easily, with relatively less effort, also expand globally. And we have the industry-leading radio performance. Like I said, we paid close attention to the design of the module, where the right hardware was envisioned early on, because we knew that this uplink would require the extra components and the design. It's a challenging design, and we had to spend a lot of effort to get it just right, because there are lots of design challenges when you are dealing with 4 antennas and so many frequencies and so much support that's needed, and also in a very tiny size. And overall, this is just showing all the aspects of capability that Telit has built over the years to support our customers in terms of everything that we stand behind. And now 5G is very exciting and new technology that we are working on and bringing to our customers. Long-term continuity of supply makes sure that products can continue to sell for a very long time, especially in those use cases when the lifetime of the product is needed to be sustained for long periods of time. And we have very good world-class support as well. So we basically handhold the customer all the way through their device to be fully certified in the industry. So I think that's all the time I think I had, and I want to wrap up so we have time for some questions. And so I think with that, I will close my comments. And now back to you, Lindsay, for questions.
Thank you so much, Safi and Donna. That was wonderful information. We do have time for just a few questions. We've saved about 11 minutes here. So please continue to submit your questions in that box to the right of all of the slides, and we'll do our best to cover them all. But before we get to the questions, we're going to drop one last poll here, just to see if there's anybody here who would like one of our experts to reach out to you. Please respond here to the poll, and someone will be in touch. So we have quite a few really wonderful questions. I'm going to start one here with Donna. Donna, can we use the LTE for IoT applications?
Absolutely. In fact, that's probably one of the largest uses of LTE that we see. And that could be IoT inside of a branch. So often what we're seeing happen is people want to drop an IoT application in. Maybe it's an HVAC application, maybe it's a security system. We actually have a partner who's deploying heat temperature sensors at doorways of buildings. So as people return to work, they can do temperature sensing. And they often don't want to put that on their existing corporate WAN. Their IT department maybe is uncomfortable with security ramifications, or they just want to drop this in as a completely separate network. So they actually use a cellular link, Gigabit LTE, to create this separate parallel network that's completely air-gapped from their wired WAN, but still gives them all the management, visibility, et cetera, that they need. So that's a really good use case we see with IoT. And then we also see quite a bit of IoT, like I mentioned, security cameras, smart city applications of different types, digital signage applications, or monitoring, particularly out in fields and agricultural, oil and gas, mining types of operations, where they will want to connect that information. They need bandwidth, but of course they don't have the ability to run a wire. And so that's a huge use case for Gigabit LTE.
Okay, thank you. And this next one seems to be appropriate for Safi. Safi, modems don't typically have MIMO uplink today. Will that be changing?
That's a good question. So yes, when I touched on the recipe for Gigabit LTE, right, we talked about 4x4 MIMO in LTE. Now, obviously, that is in the downlink direction because the base station has the most resources and can transmit even more than 4. But essentially, for a device like the LM960, we do have 4 antennas for our receive. So we can actually do full 4x4 MIMO on the receive chain. And that's how we achieve the 1.2 gigabits per second full speed of the downlink. Yes, on the uplink, we can do carrier aggregation. And as I explained, that's basically just tuning the different frequency bands within the module to be combined. But then they are transmitted using a single antenna because, of course, on the uplink, the device wants to conserve as much space and power. So that's constrained. So yes, agree that the 4x4 MIMO is used in the downlink.
And I would just add a note to that when you said that modems typically don't have it. That is true. I mean, you have to have a modem and then a router that was designed specifically for Gigabit LTE. So we've seen routers that used to support things like Cat6, Cat12, say that they now support Gigabit LTE, but unless they've reconfigured their antennas to support the full 4x4, they're not going to get the full performance that you would expect from Gigabit LTE.
Great, thank you. And Donna, this one seems to be appropriate for you as well. Somebody is asking, did I just hear the maximum UL data rate is 150 Mbps?
If that's what Safi said, then he's definitely the expert in this.
Yes. So typically, if you don't have the carrier aggregation available, then you will be capped at 75 megabits per second. But if your module does 2 carrier aggregation that doubles the speed, you get up to 150 megabits per second.
And I would say that is, if you look at bandwidth usage, particularly in the use cases that we both went through, that has not been an issue. That does allow you to upload video. It allows you to do most of the normal enterprise activities that you would do in a branch or a vehicle. We still have many customers that are on MPLS, which most of them aren't on a single T1 anymore, but 150 megabits upload is pretty good performance and supports most of the enterprise use cases we discussed.
Great. And then this could be for either one of you. We've got, mobile carriers infrastructures hardly support hundreds of thousands of users each with gigabit connection. What about that?
Yeah, I can take that. Yes, so the capacity planning by a mobile network operator essentially is driven by their user profile, right? Mostly the handset users are the big data hogs, and they basically plan for capacity by having base stations spread across. And in dense urban areas, that density goes up. So they put not only the macro base station, they also put picocells, they put macro cells, microcells, and even femtocells inside buildings. So they plan for that capacity. And most of the smartphone users might be watching a video, so they may not be doing a lot of uplink. Now, in the branch office, uplink is very important, and so multiple users within a branch office, that bandwidth is also dimensioned by the provisioning office to make sure that you have adequate bandwidth in the uplink for the number of users that you expect to be using the network.
Okay, excellent.
Yeah, and I would just add to that, I mean, the mobile networks are evolving, and we work very closely with many carriers, and they are increasingly looking at the enterprise use of wireless as a growth area for their network, particularly with Gigabit LTE and as they roll out 5G. So they are expanding their capacity, they're upgrading the core of the network, and they are re-engineering for more continuous use, because the question was right. Wireless networks originally were intended for limited connections and not a lot of continued connections. In fact, that's one of the reasons why it's important to work with a modem provider like Telit, so that you can make sure that you hold and maintain a connection, because many of the sort of consumer-grade modems were intended for intermittent connectivity instead. So I think, this, as well as data plans, are evolving as carriers become more interested in supporting that enterprise use case.
Thank you. I think we have time for one or two more. Let's see. Safi, could you talk about the main difference between uplink and 5G and LTE? And can uplink and LTE match 5G with new advanced features?
Okay, yeah, that's a great question. So 5G is already here, and it would take another whole webinar to explain all the features of 5G, but I'll try to, in a nutshell, say that no, LTE uplink is what it is today. 5G is bringing an entire new swath of very big, very wide spectrum called millimeter wave. And so your highway just became like super wide, just going back on the same example as I said earlier. So in 5G, your uplink will actually be much, much higher. And that, if you can just imagine, in LTE, 5 carriers of 20 megahertz get combined for downlink, and two carriers are combined for uplink, and those are 20 megahertz each. So you have 40 megahertz of spectrum for your uplink. Now in 5G, for example, your overall width of the spectrum increases by a few orders of magnitude, because in millimeter wave you have 800 megahertz bandwidth, for example. So you can imagine that the uplink speed will go up dramatically. In our 5G module, the FN980M that we are designing, our highest uplink is going to be 3 gigabits per second. So you can imagine jumping from 150 megabits per second uplink to almost 3 gigabits per second uplink, where the right conditions are available and the network is properly deployed for that feature. So no, they will not be the same. They will actually increase dramatically.
Thank you. And I think we can squeeze one more in. I've got a good audience question here. I think both of you would be able to speak to this. Where can we get more information about configuring the band interlacing for shotgunning the modems?
I don't know what shotgunning a modem means, but this is something we can probably respond offline. I don't know what that means.
Yeah, and I got nothing. Safi's definitely more knowledgeable than me on that.
Okay, well, and we have hit the top of our hour now, so, we will get to some of these questions, folks, independently, so we'll make sure that we get your answers for you. And we just wanted to say thank you so much for joining us. Thank you so much to our gifted speakers today. Really great information. And check your inboxes in the coming days. Audience members will have the slides and the replay link for you. Thank you all so much.
Thank you.
Thank you.